Hi, I'm James McGuire, and today we're talking about software and hardware in your data center, mostly hardware. To discuss that, I'm joined by a real expert on the topic. With me is Colin Presley, Senior Director, Office of the CTO at Seagate Technology. Colin, very good to have you with us today.
Yeah, it's really good to be with you, James. Thank you.
It's interesting. The enterprise IT industry is really really obsessed with software. It seems like there's that famous quote from Mark Andreessen. Software is eating the world. Everything's software defined. We're mainly going to talk about solid state drives and hard disk drives today. So we're mostly talking about hardware. Can we still feel like we're sort of hip with it, guys, even if we talk about hardware?
Oh, absolutely. I think Seagate, we're a hardware company fundamentally. We are moving more into software, and we understand that software is a big piece of the world, and software defined is there because the world is changing so quickly. And for the world to change quickly, you really need software to be able to make that change. What we see more of is such an open ecosystem now in software, and that's actually moving into open in hardware as well,
Hmm.
where massive developer communities are developing software together as an industry, because the industry problems are so big that we really need to solve them together, not individual companies. So yeah, we absolutely acknowledge software is a big piece. What I think we see is that we need to necessarily maybe reduce the cost of the software, because
Hmm.
the cost of the software can become prohibitive to the ecosystem growing. So anything we can do to help grow the open communities and reduce the cost of the software layer, we can drive more value towards the hardware, and ultimately the whole ecosystem can grow that way.
All right, interesting. And of course, and this point doesn't always get made that all those software defined infrastructure, it all runs on hardware. I mean, it feels like hardware doesn't get as much buzzy headlines these days, but the hardware is there. Whenever you use the phrase software defined infrastructure, it runs on hardware.
Oh, absolutely. And I mean, that's such a key point, right? Now, software developers may not want to know what the hardware is,
Right.
but ultimately the hardware has to be really, really efficient. We're seeing a lot more direction on the hardware side to go to domain-specific acceleration, where specific types of devices and compute functions are getting abstracted so that they can be super efficient, whether it's smart NICs or FPGAs. Now, all of those ultimately get abstracted at the software layer, but gluing together the software and the hardware with all of these abstracted hardware pieces is just becoming more and more and more prevalent as we go forward.
Yeah. Well, I think there's an interesting, I call it a debate, maybe it's a macro trend in the IT industry where, the hard disk drive has been the legacy drive. And of course, it feels like it's being overtaken ever so slightly, maybe not so slightly, by the solid state drive. Flash is so fast. And some analysts say, hey, we're coming to a day where the hard disk drive is going to reach its sunset, and everything's going to be flash dominant, especially as prices have fallen. Is that how you see it? How do you see that particular macro trend working out?
Yeah, no, that's really not the way we see it at all. Now, solid state devices are really incredible devices, and there's a lot of innovation going on in that space. And absolutely true, their prices has fallen, and they're in a different class relative to performance from a hard disk drive.
Right.
So all of those things are true. But if you really look at it, I mean, the cost differential is still very, very high. I mean, you're talking at least eight to 10x from just a device cost perspective.
Huh?
And while it's pretty easy to find use cases where it makes sense to move from an HDD to an SSD, maybe in consumer solutions or areas of enterprise performance where performance really dominates, or other metrics, absolutely it makes sense. And we've generally, our mission critical, while our mission critical business is still reasonably healthy and we're still selling those types of devices, we clearly see that there is a transition there from the type of devices where you require significant performance. But we like to look at it really that they're not essentially competing technologies. They're very complementary technologies. We need SSDs to be successful as an industry, to be able to grow hard drives, to be able to grow storage. I mean, we shipped 1 zettabyte of storage last year as an
Wow.
HDD industry. I mean,
Okay.
it's a massive amount, and we're
Yeah.
anticipating to ship 4 more zettabytes in the next 5 years. I mean, the
Huh.
amount of storage that needs to be created is just immense, and we need SSDs and HDDs to be successful for that.
It's really interesting. I didn't realize that the 8-to-1 cost difference. I knew there was a big one. I didn't realize it was something like eight to one. That's pretty amazing. What about the total cost of ownership of hard drives versus the total cost of solid state drives at scale? So I know that obviously the flash drives are really the high performance, and sort of the sports cars of the industry. But what does it really work out in terms of total cost of ownership between the two formats?
Yeah, so maybe just the first one on total cost. Total cost of ownership is a very important metric. We deal with it all the time. Our customers do. Anybody that's deploying storage at scale needs to understand their total cost of ownership.
Mhm.
Uh, to put it in perspective, there's typically an operating piece to that and a capital piece to that. The operating piece is around support, power, anything for that device to live for, say, 5 years in a data center is on the operating side. And then there's a capital piece, which is how you're going to deploy that device, the cost of the acquisition of that device.
Mhm.
Um, so all of those pieces go into the capital piece. So and it's very important for everybody to understand that. I mean, the 8 to 1 ratio we mentioned is really just on the device cost. Um, so there's been some points made that, for example, on the power side, that the SSDs can be less power than HDD, and that's absolutely true.
Hmm.
Um, but when you really look at it in terms of the Pareto of what makes up total cost of ownership, at any kind of scale, the device cost dominates extremely in that equation, the
Hmm.
device
Okay.
acquisition cost. So it's really
Okay.
about how much the device costs and the cost per bit. And that's what we're really focused on, because these other pieces, while they are important, and there's lots of people working on how do we make power more efficient, how do we make slot costs lower,
Mhm.
how do we drive down the cost of the ecosystem and the software layer that we've already talked about.
Mhm.
Ultimately, when you're really deploying storage in mass storage deployments, it's really about the cost of the raw storage that you care about.
So that would, in other words, that would favor the hard disk drives, which of course have a far smaller sticker price. So in other words, does it dramatically favor the hard disk drives over the solid state drives?
Oh, absolutely. I mean, we're talking probably at least 6x, we think right
Okay.
now, and
Oh.
that equilibrium we think persists for the next 10 years. Because
Hmm.
if you look at the actual cost of the devices and how they're changing over time, uh, we're on about a 20% cost per terabyte reduction, as in solid state is on the similar curve. So
Per year, you're saying, or what is the
right,
20% figure?
right,
Okay. Yeah.
on a CAGR basis. So
Yeah.
uh, because essentially that equilibrium is working now in the industry, we don't really see that changing. So while yeah, there are some aspects of total cost of ownership can favor SSDs, that it really still is a massive difference in terms of the total cost of ownership delta between the two that favors the HDD in the mass capacity deployment.
Interesting. Well, I'd be interested to sort of take a glimpse inside the average cloud data center. What do you think the ratio of hard disk drives to solid state drives are in the average cloud data center? It's sort of like saying what's happening in the real world out there.
Yeah, so this is published pretty well, and we have some articles coming out too. About 90-10 is what we typically see, and that's that translates across most mass deployments and cloud data centers. And that 90%, 10%, that is just total deployed exabytes. If you actually talk about what is deployed within the mass storage pieces of that, it's actually a much higher ratio towards the HDD, because
Hmm.
there are some applications which are purely solid state. You can call them storage and they're exabytes deployed, but they're really in support of very high compute functions. And so it really just depends on how you slice that. But the 90-10%, 90%, 10% ratio works really well in the general case. But in the mass capacity case, it's actually more skewed towards the HDD.
It's interesting because I wouldn't have thought of it. It's quite that high because if you look at the consumer world, of course, the gadgets that run our world, our phones, or if I go out and buy a new hard drive now, it's probably going to be a flash drive. Often is. So it seems like the consumer world has made more of a switch to solid state drive than the enterprise world. Does that seem accurate?
Oh yeah, that's absolutely accurate. And I think that's sometimes where some of this confusion comes in, is the devices we see every day and we work with, and our laptops and our phones are transitioning that way. But I think what the pieces people don't see is that what those things are actually doing is they're enabling really more storage in the data center, right? Everybody's taking photos on their phones, they're
Right.
using those devices. IoT now is just emerging, where we strongly believe that whereas we've been in the consumer world with this cloud environment, a lot driven by consumer data, that's now transitioning to actually machine data. We haven't even really got to that point. Now, IoT devices are going to be talking to each other, transmitting data.
Oh,
Cars are going to
right.
be transmitting data and talking to each other. all this
Right.
data is just going to explode.
Right.
Uh, and it's data that we don't necessarily see and interact with as a user, but
Mhm.
that data has to go somewhere. And
Right.
it ultimately ends up in the data center. So yeah, while the use cases are shifting a little bit, and sometimes the pieces that we interact with as consumers shift, if you look at it back at that exabyte and the TAM for storage generally,
Mhm.
I mean, it's doubling every 3 years. I mean, the
Wow.
TAM for the data sphere was about 50 zettabytes last
Okay.
year.
Yeah.
It's doubling every 3 years.
Which I mean, I know I've seen that figure a lot. I find it to be amazing. I'm not sure that figure is commonly known outside of the tech world, but it raises a question we don't need to address today. But the question is, where are we going to store all that ocean of data? And I have no idea because we are making more and more and more data, even as we humans are very, we're a data intensive bunch to be sure.
Absolutely, and it's a challenge for the whole industry, from the highest speed memory to the lowest speed memory. I mean, we're a big piece of it, and we're trying to address it. But everybody has to rise to the challenge. At the moment, we anticipate only a fraction of that data that's created is stored. We think maybe in the 3 or 4% range.
Ah,
But we also know with AI ML, for example, and those types of techniques coming forward, more
right.
data generally is better as we go through training those types of
Definitely.
activities, right?
Right.
And often with those type of applications, we don't know what we don't know, right? There's a desire to go back in time and retrain models based on historical data. So we
Mhm.
keep hearing that people would love to be able to store more of their data, but they can't just because of the cost piece of it. So driving the
Right.
cost down further and further will just allow people to store more data and more industries to
Mhm.
use it.
Mhm.
So
Right. Well, certainly the solid state drive has plenty of arguments in its favor. I mean, what about the idea that it's a positive for the solid state drive to rely on the TBW and the data reduction technology? What's that about?
yeah, so there is this concept of essentially effective terabytes that gets used sometimes in the solid state world.
Hmm.
Essentially, what we're saying there is that you can compress your data. You can use the fact that solid state drives are very, very high performance. You
Hmm.
can do techniques like deduplication, compression, and you can generate essentially effective terabytes and make your storage look bigger than it actually is. And you can use ratios there. And that is absolutely all fact and true. Uh, but what really isn't true in that equation is one, hard drives can actually do the same thing.
Right.
Uh, while hard drives themselves, the performance is clearly orders of magnitude different than SSDs.
Hmm.
It's actually amazing how much you can do with just a small amount of cache on the front end of a hard drive cluster, and distributed RAID system, for example. In fact, we've actually got an article coming up in our DataSphere event we're going to be hosting soon. We're going to be talking about that a little bit more, but we've demonstrated pretty effectively that we can achieve 4-to-1 compression of data on just a regular hard drive enclosure, and still keep very, very reasonable performance as well. So the other point in that area as well to make is often when hard drives are deployed, the deduplication and compression is actually done at the layer above the storage.
Okay.
So it'll go through, say, an SSD array or some other layer, and it will be compressed and deduped, and then it'll end up on the storage. So it's again a
Ah,
bit of a moot point. And
okay.
maybe just the last one to make there is encryption defeats compression. And we're seeing more and more the world going to encrypted data for security.
Hmm.
But once data is encrypted, there really is very little opportunity to be able to do those techniques. So
Hmm.
while all of the facts are true on the SSD and that effective terabyte case, it's really a bit of a moot point relative to mass capacity deployment.
It's interesting about the encryption defeats compression. I didn't realize that. Is that something that they're working on to be able to compress encrypted data, or is it simply probably technologically not going to be in the near term future?
No, there really is no solution to that,
Hmm.
because once you put data through the encryption algorithms, essentially the entropy, that's how you really measure good encryption, is the entropy of the data before and after that technique. And the data becomes so scrambled at that point that really is very, very minimal capability to do any
Uh,
kind of deduplication or compression at that point. So
Interesting.
really you're stuck with having to do the compression pre-encryption. So then it really just depends a case of where the encryption is done within the stack.
Mhm. Well, and certainly if you look at the hard disk drive as a format, I mean, it's not, I mean, it continues to be, it continues to evolve in terms of its capability. I mean, there's things like the HAMR, there's dual actuator technology. You know, I'm assuming these are some of the things that are really keeping the hard disk drive alive going forward.
Oh, absolutely. For us, we see massive room for innovation still within the HDD piece.
Hmm.
Clearly,
Yeah.
perpendicular recording, which is the recording technology we're currently on, its predecessor was longitudinal recording.
Hmm.
Perpendicular recording is somewhat coming to the end of its life. We see diminishing returns right now in terms of growing areal density with the perpendicular technology.
Hmm.
But yeah, HAMR is we call it HAMR, heat-assisted magnetic recording.
Right.
That has a massive promise for increase in areal density. We just had a recent analyst event where we showed some of that data. We have lab demonstrations showing devices that could go to 50 terabytes by 2026,
Hmm.
even 100 terabytes by 2030 potentially.
Wow. Okay.
So that allows us to fundamentally really increase by increasing the coercivity of the disk and then using heat to essentially temporarily lower the coercivity as we write it, we can achieve massive increase in areal density. So
Hmm.
with heat assisted, and we're already shipping that technology today, and we have plans to transfer to that over the next decade, and it'll provide us a really big boost.
Interesting. Okay.
On the
Well,
performance side, I mean,
go
you
ahead. Yeah,
mentioned
please.
you mentioned dual actuator, for example.
Yeah.
So as we increase capacity with HAMR, we also do need to address areas where some customers become starved of their capacity because they don't have enough performance.
Hmm.
So even though we're not still trying to compete with a solid state drive in performance, what we're trying to do is keep the access to the data to a point where it's useful for customers. And so by adding in a second actuator to the drive, we're actually now able to double the amount of accessible capacity for customers that become constrained.
Hmm.
So we also have a solution to that to match with HAMR. So yeah, lots of innovation in the hard drive business.
Huh? Okay, I did not actually know that. All right, so the hard drive, which sometimes is seen as a less glamorous part of the duo, is moving forward. What about the role of the cloud service providers? I mean, the big players like Microsoft Azure, AWS, Google Cloud. I mean, obviously those platforms have got really big budgets and they're enormous amount of performance pressure on them. How do the hyperscalers balance between the solid state drive and the hard disk drive?
Yeah, so the hyperscalers have now become, lots of innovation within the hyperscale. They really are leading.
Mhm.
As we've said before, really, that they are the epitome of deploying at scale.
Right.
And so for them, they are optimizing efficiency everywhere, from data center infrastructure to storage infrastructure to compute, up and down the stack. For them, trying to drive efficiency is what it's all about. And we are, talking to them all the time and trying to develop the best solutions for them.
Mhm.
Absolutely, they are proponents that all of these technologies are important. Solid state's important, HDs are important, and how you compose them together to make the most efficient system is really what it's all about. So, uh, you know, it's a massive business, and it's just a growing business in the hyperscale.
I mean, I guess my sense might be look without. I mean, I just pick a company like Amazon Web Services, obviously with enormously deep pockets. They would just go, "Oh, forget it. We'll just go ahead and buy the most expensive thing because we're not cost conscious at all." So, in my image, the Amazon Web Services would be completely staffed, full of solid state drives. You might not know the form. I don't know, but is that true or not necessarily?
Oh no, I mean they have everything, right? But
Yeah.
they just have such a massive amount of demand for storage, right? They're growing at such a rate.
Right.
They're with everybody else. They're in the similar ratio of 90-10% on the
Hmm.
HDD SSD.
Okay.
Uh, it's clearly there's tiers of storage, and they offer. I mean, it's public information. You can go out and you can buy solid state storage tier within AWS or other
Mhm.
cloud providers. You can choose to do that, and they have tiers all the way down to Glacier type storage. So
Huh.
you can absolutely do that, but clearly, really the sweet spot still is that 90-10% ratio
Hmm.
where most data can live on hard drives. I mean, one just to address that point again with performance, you have to remember that once you put disk drives at scale, they become a very paralyzed solution. You if you pair disk drives with good parallel file systems, which all of these people have now, you can get very good performance off disk drives. I mean, one shelf, one JBOD can service something like 5 gigabytes per second. I mean, it's very, very good performance in the scheme of storage. Remember, with SSDs, if you want to scale, if you have that kind of performance, while it's very good on an individual device level, to scale that performance, you have to also scale compute and scale network with it. Otherwise, you just become saturated at other points along the stack, right?
Right.
So, and if you don't, then you end up with stranded performance. So, yeah, I mean, the point about hard drives and performance is once you put them at any kind of scale, you actually achieve reasonably good performance as long as you can keep that data distributed across the disk drives, which all of these guys can.
Well, no doubt. What about? I mean, we do hear a lot about the impressive levels of the solid state drive. I mean, it is seen as the fast, the high power format. Surely the data does bear that out, right? I mean, is the SSD is as impressive as we hear it is in the enterprise IT format?
Oh, absolutely. There's no doubt. I mean, it's in a different class. But I mean, if you just look at all the different classes of memory, so you have DRAM, and then you have storage class memory, and then you have solid state memory, then you have hard drives, and, so there is a continuum there, absolutely, along with performance. So I mean, that is without doubt. The real question is, can you make use of that performance? And if you can't, then you're paying for performance that becomes stranded. And that kind of comes back to are you willing to invest in the networking? Are you willing to invest in the compute side to really make use of the storage you're buying there? I mean, back to the AIML case, solid state drives can have a good application there with an all-flash array attached to a training system, for example, where you need to be able to iterate on a lot of data very quickly, but you also then have to pair that with a mass capacity storage system that's in the back end, because you have to keep all that data somewhere, and you're not going to keep it on solid state drives there. So yeah, there's no debate in the fact that solid state performance is clearly outclassing HDD, and that will always be the case. It's really a case of, are you wanting to deploy or willing to deploy the infrastructure around it to make use of that performance? And if you don't have a workload that demands it, then you're paying for performance that just becomes stranded.
Right. Well, let's zoom out a bit. Let's look to the future. What about the trends in the data storage industry and in the hardware data or software the data storage industry in the years ahead? Say if we have this conversation several years down the road, what do you see happening, and how might a company get ready for that now?
Yeah, so one big trend we see is composability and disaggregation as a general trend. So there was a phase where companies went to hyperconverged infrastructure for ease of deployment, where you would put storage, compute, networking together. Now we're starting to see a trend away from that and more towards composable architectures, where you tend to see optimal systems for storage, for compute, for networking, acceleration. And these are all backed by new fabrics like NVMe over Fabric. And there's new ones like memory disaggregation. And by being able to disaggregate all the components of the ecosystem, you're now able to scale independently. Whereas before, when you converge everything together, you become locked with certain ratios of storage, compute, memory. And by disaggregating everything, now you've got to a point where you can scale them differently. And that comes back a little bit to the software too. Once you've now got to a hardware disaggregation, that really enables new techniques like containers and Kubernetes, these types of technologies which can compose different services and storage and compute above the devices. It allows much easier provisioning of those, because now you can access those types of resources on demand and be able to scale them independently. So that's a really big trend. So other ones, are security is clearly a big one, massive for the whole industry, end-to-end security, with a fundamental tenet of security at rest. So we see, we've had SED or storage, security devices for years now, but we're seeing much more prominence in people wanting to secure their data at rest and in flight as well. So those two are big ones. And then back to the software piece, object storage, we just see that is growing and growing and growing. People need big, cheap ways of storing data. And object storage is really, really good for that. And it has very rich metadata associated with it. So the ability to find the data and be able to use it and unlock it, feed it into different AI ML algorithms. Object storage is really, really growing. And there's a very vibrant open source community too that we're now contributing to with Seagate's Cortex solution as a way of really unlocking the value of object storage and making it cost effective for the world.
Object storage can handle unstructured data better, like for social media. Is that true or not necessarily?
Absolutely, yeah. Unstructured
Yeah.
data with associated metadata is really what it's all about, and being able to handle that not only cost effectively, but it has really good search capability and also scalability. So you can scale it to different geos and geo-replication and those types of techniques.
Neat. Colin, I think you've said it. I mean, I think that the storage industry is really going to be in the spotlight in the years ahead. I mean, we're gonna need to store all this data we're creating somewhere. So I really appreciate you talking with us, sharing expertise. I will send you the link when the video is done, and we can all tweet it. Thank you very much.
Thanks, James. Really appreciate talking to you. Thanks.